Okay, welcome back. So in this part of the lesson, we're going to learn how to take the program we already wrote that has a couple of images on a canvas, and we're going to learn how to make those regions clickable using the same kind of idea as systems of inequalities. To do that, make sure you've turned in the link to your previous program, and if you closed the page, go to Profile to find your existing programs. In your profile, you're going to look in the Projects area and click View All. Okay, and then you should see your most recent projects that you've done located here. Open your most recent projects. And then I recommend we save a copy of this so that we don't overwrite what we already turned in. So you're going to click the button that says Spin Off. And then give it a new name. The screen is a little fussy. And we'll call it Buttons, for example. Okay, and now you've got a fresh copy of the program with a new name so you don't overwrite the old one. Now, one of the first things I'm going to do is I'm going to add a draw loop to this program. The draw loop is like a function that you add around all these lines of code, and it makes these lines of code run repeatedly over and over again. It gives us the ability to over and over again look for a mouse click and see if we've clicked in a certain region. So at the beginning of your program, you're going to enter a couple of blank lines, and then type in var draw equals, and then it populates the rest of this with a line of code. So you type var draw, all lowercase, type an equals sign, and it should fill in function, open and close parentheses, and a set of curly braces, and then a semicolon. Take this second curly brace and the semicolon, cut it with Control X, and you're going to paste that at the very bottom of your program, below all the lines of code. So what's happening now is your drawing is taking place over and over again inside this draw function. Any code that we add from here on out, we're going to add inside the draw function. So make sure when you add new lines of code, you put it before that last curly brace and that semicolon, okay? Now, inside the draw function, one of the things we'll do over and over again repeatedly is we'll check and see if we've clicked the mouse. This Khan Academy program has a built-in variable called mouse is pressed, and that built-in variable becomes true when you've clicked the left mouse button. So if that variable becomes true, we can make certain things happen on the screen, and that's the first thing you'll learn to do. So to check to see if you've pressed the mouse, you're going to use an if command. You type all lowercase if, and then inside the parentheses, we're going to type mouse is pressed. There's a capital I, capital P, end the parentheses, and then you put an open curly brace and a closed curly brace. Now, it's going to check over and over again to see if this mouse is pressed variable has become true. If the variable is not true, it skips whatever code is inside the curly braces. But when mouse is pressed becomes true, it will do the code inside those curly braces. So, for example, we could just say background, and we'll make the background red. Okay, so make sure you end that sentence with a semicolon. And when we test the program, if we click the mouse anywhere inside the canvas, the background turns red. As soon as I let it go, it's just going to draw the background like normal. Notice the background is like the last line of code that's inside that draw function. So it'll draw all this other stuff and then checks to see if I've clicked the mouse. And if I've clicked the mouse, it draws the red background over top of all of that. So you can't see anything else on the screen, just the red background. Okay, so far so good. And now what we're going to do is inside this, this function, I'm going to get rid of the background call because I'm going to replace it with some other stuff. Inside here, we not only want to check to see if we've clicked the mouse, we want to see if we've clicked in the right coordinates to activate a certain message. So we'll model that as a system of inequalities. Now, for example, in this rectangle, there's a certain set of x and y coordinates that are inside it and a certain set that are not inside it. I'm going to bring up my drawing so you can see what they look like on the drawing grid. Okay, so in this snip and sketch program, you can see I've drawn where these items are according to the coordinates. The rectangle starts at 100, 50, and it ends at 200, 100. And then this is where the triangle is on the screen. You just can't see the coordinate grid. So for example, if I have my mouse at the location 150, 75, that's inside the rectangle. But the coordinates 50, 75 are not inside the rectangle. So I'm going to need to check to see if the mouse's coordinates are inside the rectangle or not. Well, what coordinates are inside the rectangle? It's the set of coordinates that are bounded by these 4 lines, basically a system of inequalities. If I take, I'm going to grab a different color pencil here. If I imagine this side is like a line, a vertical line like that, and this side is a line like this, and then this one is an inequality such that the x-coordinate is greater than 100, and this one is an inequality such that the x-coordinate is less than 200, where these regions overlap, that's a valid x-coordinate that's inside the rectangle. So to check for the x-coordinate, I'm going to use a special variable called mouse x, and yes, there's a matching special variable called mouse y. So I'll use an if statement and say if mouse x is greater than, let's see, what's my x-coordinate? 100. And then I also want to check to see if the mouse coordinate is less than 200. Well, the way I check both is to use an AND operator, and the AND operator is 2 ampersand signs. These are what you get to them by doing Shift 7. Shift 7 and, okay, mouse x is less than 200. And then since this is an if statement, it also needs a set of curly braces that are inside the original set of curly braces. So if mouse x is greater than 100 and mouse x is less than 200, then I'll change the background color to red. Okay. If I check my program now, you can see if I click out here, it won't activate. If I click out here, it won't activate. But if I click in here, the background turns red. Problem is it's only checking the x coordinates. If I click down here, it also turns red. So I also need to check the y coordinates. So right now I've only checked to see if the mouse x is greater than 100 and less than 200. Let's also check the y coordinates. Going back to my drawing, my y coordinate has to be greater than 50 and my y coordinate has to be less than 100. Both of those at the same time. See how I'm modeling these kind of as like linear inequalities? So I'll do another and mouse y has to be greater than 50 and mouse y less than 100. Oh, I don't need, check and make sure all your parentheses match. For every beginning parentheses, you should have an end parentheses. No curly brace here, or sorry, no semicolon here, no semicolon here. You have semicolons at the ends of complete sentences, but not right before a set of curly braces there. Anyway, now I should be able to click here and the screen doesn't turn red, but if I click exactly inside the rectangle, the screen turns red. Does it matter if you do greater than or equal to? Greater than or equal to looks like this in computer programming. There's the greater than sign and then the equal to. It doesn't matter too much. The line is only 1 pixel thick, so it just makes, all it will make it is give you like 1 extra pixel of clickable area. You can click here or click like really close to the line. So the greater than or equal to doesn't matter a ton if you don't care how precise you are. So that's how you make a clickable rectangle. As a bonus exercise, the clickable triangle is kind of a fun challenge. So if you think about what it takes to make a clickable triangle, we'd have to find a way to model all 3 of the sides as lines, and then think about the linear inequalities that would make it so that you're bounding the area inside the triangle. So our 3 lines that we'd need to make sure we're modeling are this line, and then this line. Now my vertical line's easy. My vertical line is just x equals 200. Okay, and then the inequality would be interested in this side of that line. So that's all the coordinates where x is greater than or equal to 200. So that's how I'd model that one. But the other 2 lines are slanted. My suggestion is you figure out what the equation of the line is in slope-intercept form, and then model it so that if you're looking at the region above the line, it's like y greater than, or y less than that number, because lower values of y are up. And if you want to interested in the area below the line, it's y is greater than that number. So here's what I'm talking about. Let's say this line, I'll look at this line. This line, for example, goes from 200, 350. So 200, comma 350, all the way down to the corner, which is 400, 400. Okay. Now to write that in slope-intercept form, I can do this by knowing 2 points. First, I figure out the slope, and the slope is the change in y divided by the change in x. So the change in y is 50. It's 400 minus 350, so 50. And the change in x is 400 minus 200, so 200. 50 divided by 200 is 1/4, or 0.25, right? So that's the slope. Next, we're going to figure out the y-intercept by plugging it into a slope-intercept form equation. So we'd say, I'm going to start working up here, y equals 1/4 x plus b. Okay, and now let's plug in an x and y value we already know, like let's say 400, 400. 400 equals 1/4 of 400, so that'd be 100, plus b. Well, b must be 300, so that's the y-intercept. So your full slope-intercept form of this line right there, the one that goes from 200, 350 to 400, 400, is y equals 0.25x plus 300. And now since I'm interested in the region that's like above that line, so this area up here, I want all the y values that are less than that line, because you see the y values get lower the more we go up. So the way I'd write that inequality is y is less than 0.25x plus 300. Okay? The last line on this triangle is a really easy one because it just goes from 200, 200 to 400, 400. This is the line y equals x, because the x coordinates are always equal to the y coordinates all the way down this triangle. It's a really simple one, so we don't need to go through the whole process. We can just say this one is y equals x, and we're interested in all the coordinates where y is greater than x because we want the lower side of that line. So our third inequality is y greater than x. So we've got 3 inequalities that we're going to check if they're all true. The first one is x is greater than 200. The second one is y is less than 0.25x plus 300, found by doing the slope-intercept form of that line. And the third one is y is greater than x. We model all 3 of those as inequalities in this program, and that makes that region clickable. So here we go. If, okay, now instead of the letters x and y, we'll use mouse x and mouse y. So mouse x is less than, that's not right, it's greater than 200. Oh my goodness, and let me go back to my snip and sketch so I can see. Mouse x is greater than 200, and mouse y is less than 0.25x plus 300 is less than 0.25x plus 300, and mouse y is greater than mouse x. And I didn't mean to write x there, I meant mouse x. And you can't just put a variable next to a number and expect it to know you're multiplying. You have to be specific and say it's multiplying. So we'd say 0.25 times, that's this little asterisk operator, mouse x. Computers know to follow order of operations, so it will know this operation is done first and then you add 300. But since there's an awful lot in here and it just helps to separate everything, I like to put parentheses around all of my little inequalities so that I just know they go together. And then this one has a set of parentheses too. And lastly, I'm going to put parentheses around this whole phrase, this whole conditional statement. And don't forget, you need a set of curly braces. That is all the code you're going to do if you clicked in that triangle. And so now here's the moment of truth. Let's make this background turn like green. if we click in that region. So if we click out here, nothing happens. If we click inside the triangle, it turns green. We modeled the inequalities the correct way. So just to recap, I'm going to go to a document here to review those steps. If you're doing a rectangle, you can model the four sides as really simple inequalities. So mouse y is greater than or equal to number, mouse y is less than or equal to number, mouse x is greater than or equal to number, mouse x is less than or equal to number, and you'll use an if statement that kind of looks like this. Sorry, that should be a capital Y. And I'm writing just the words number. You, of course, are going to fill these in with whatever the bounds of your rectangle are. Okay, and then you do a set of curly braces, and whatever you want to happen when you click there, that goes inside there. And then triangles are a little weirder. You have to find the slope of your line by subtracting your y coordinates and divide that by the difference of your x coordinates. You plug that into the equation y equals mx plus b and find b. Turn the line into an inequality. If the clickable region is above the line, you'll use something like that, and if the clickable region is below the line, it'll look something like that. So then your final inequality will look something like this. If mouse y is less than or equal to whatever the slope is, make sure you use that asterisk instead of the just putting the number next to the variable. Put in some number, that's the y-intercept. And then you'll do an and put in your other inequalities here. I'm just making these up, so don't use my equations. I don't even know what these are. Okay, you'll write out your whole system of inequalities as little logic expressions here, and then whatever code you want to happen goes inside the curly braces. So that's the style that you would use for a rectangle button or a triangle button. To prove that you understand this at a basic level, you can do all rectangle buttons, and if that's as far as you get with it, that's fine. Pardon my dog. Hold on, sugar. To show you're advanced, do the triangle regions. Okay, good luck. Have fun with it. I'm excited to see what you make. Don't forget when you're done to take the link for your project, like highlight the hyperlink in the URL, copy it, and paste it into Google Classroom as a link before you mark it as done and turn it in. All right, good luck. I hope you do a good job.